Welcome back, students. In this session we are discussing about the cycloidal curve. In the previous video I have discussed about cycloid, first curve of cycloidal curve. Now we are discussing about the second curve, epicycloid. Epicycloid is a curve that circle rolls on another circle or another arc externally. So simply I can take a curve formed by rolling of a circle onto another circle, arc or curve externally. For this we should require generating circle radius, generating circle. I'll be taking generating circle radius as smaller, and directing circle radius. No problem if the diameter is also given, you can make it into half and you can apply the formula for this. So for this we should get a formula of theta capital R is equal to theta is equal to small r by capital R into 360 degrees over here, and I'll be taking an example of small r 20 mm, and the directing circle radius has 60, right? So I'll be getting a theta over here is this much, that would be equals to 120 degrees theta. So this angle would be 120 degrees over here. So for this already we have calculated 120 degrees. So coming of drawing this circle, drawing this curve, I'll be placing the figures centrally like this, not like this or like this. So I'll be placing the curve centrally, so I'll have to take the 120 degrees here. So actually this is the 0 degrees, right? So I'll be taking 30 degrees over here, from this point, and 30 degrees from this point, right? So the total angle would be 120 degrees for this, and the radius we have to consider over here is 60. I'll be marking over here, that would be very easy for us. This is 60, and we have to consider the radius of generating circle as 20. So I'll be taking a 20 mm extra from here. This would be the center of generating circle. Now I'll be drawing the directing surface from this point. This would be the directing surface, and here I have to draw the generating circle. So we have drawn the generating circle, and we have to divide the generating circle into 8 equal parts. Already our drafter is parallel to this one, so this would be perpendicular to that, and here we have to make another 2 parts. So 30 degrees already is kept, So So what I have to do, we have to make it 45 degrees, 10, 20, 30, 40, 45. So we have divided into 8 equal parts, 0, 1, 2, 3, and again 8. And the circle is rolling in this direction. Clockwise. The circle is rolling in a clockwise direction. And previously we have drawn the locus lines from each and every point, as you can see in cycloid. So we'll be repeating the same locus line generation from the each and every sector of the circle from here. But because our directing surface is a arc, so we'll be following the same path as we have following the directing surface, same like this one. Because this directing surface is flat, so we have drawn flat straight lines. Here it is curved, so we'll be following the same thing. So 1 and 7 it is joining. Two and 6. 3 and 5. And 4. And we have to divide the directing surface into 8 equal parts, same like this. And I have forgotten one more thing about the center. This one. This is the center. In the previous problem, the center is passing through the 2 and 6, so no need of extra center line to draw from here. But here center line is not passing through 2 and 6, so in this situation we have to draw the extra center line from here, and we have to divide this sector into 8 equal parts. So 120 degrees by 8 parts, so I'll be getting 120 to 15 degrees, right? So I have to divide this arc into 15 degrees. I'll be placing my protractor over here, and I'll be dividing this into 15 degrees each. 15, 30, 45, 60, 75, 90, 105, and 120. So here we have divided this sector into 8 equal parts, each of 15 degrees, right? So I'll be mentioning the diameter of the generating circle also here. Here pi is 40, the diameter of this one. And similarly, as what you have followed in the previous cycloid problem, we have to locate the center C0, C1, C2, C4, C5, C6, 7, I think I have forgot one thing over here, right? This is C 3, 3, 4, 5, 6, 7, and last C8. 1, 2, 3, 4, 8, right? Now the same technique we are adopting, measuring the radius, keeping it every center. Measuring the radius. First C0 to 0, C1 to 1, C2 to 2, C3 3, C4 4, C5 5, C6 to the 6, 7 to the 7, and 8 to the 8. So we got all the points over here. P0, P1, P2, 3, 4, 5, 6, 7, and this is P8. So simply just draw light strokes. And dark it. This is your epicycloid. And how to create a tangent normal for this? Similarly, we have to select any point onto the curve, and from there we have to take the radius, and from there we have to draw a point which cuts onto the center line, and from here perpendicular to the generating surface. This is generating surface 1 2 3 4 5 6 up to 8, and we can't draw the perpendicular line like this. So to getting the point onto this, from this point just draw a line which cuts the directing surface. So from this point to the selected point onto the curve, you can draw a line that's called normal. And perpendicular to that would be your normal tangent. This is your tangent, and this would be your normal. This is the generating circle, this is the directing surface, this is the epicycloid curve, tangent, and normal. And the last curve what you have remained with is hypocycloid, And Hypocycloid also follows the same methods, same values, same divisions over here, but that would be the circle rolling inside the arc. This is your arc or directing circle or directing arc or directing surface. So inside we have to roll a circle. So I'm taking the same over here. And there is one beauty of this. If you combine epicycloid and hypocycloid, you can construct an ellipse like this. Sometime a question may comes like this also, means you have to form an ellipse by using hypocycloid and epicycloid methods, right? So similarly I'll be dividing this circle into 8 equal parts. Previous our circle is rolling clockwise direction, now our circle would be rolling anti-clockwise direction to complete this circle. So same 0, 1, 2, 3, 4, 5, 6, 7 and 8. So now this circle would be rolling anti-clockwise. This would be clockwise, this is anti-clockwise direction. So when the circle rolls like this, so it can complete the curve like this. So when your circle is rolling in this direction, it can complete the curve in this form. If the circle is rolling opposite, then again it comes over here outside, because it should not come out, it should roll inside. So anti-clockwise direction, this would be the direction anti-clockwise, and the circle is rolling in this manner. So already we have divided this, and simply we have to draw the locus arcs from each and every sector of the circle. I'm drawing 1 and 7. Now 6 and 2. Center line. Five and 3. And the last one, 4. Already we have the previous points 1, 2, 3, 4, 5, 6. No need to mention again in the hypocycloid. Just we have to take the centers. This is C0, C1, C2, 3, 4, 5, 6, 7 and C8 center. And same method we have to follow. Measure the radius, keeping at the centers. And this is a 0 division. This is 0 division, and this is 1 division, 2 division, 3 division, 4 division, 5 division. So 0 to the 0. Next, keeping on to the C1, onto the 1 locus line. This is the 1 locus arc, 1 point. First I'll poke the points onto this, so that would become easy when you place your compass onto this. From 2 I have to draw the point on 2, 2, 3 to the 3, 4 to the 4, 5 to the 5, 6 to the 6, 7 to the 7 and 8 to the 8. So we got points like this. So this is P0. I'll take this as P1 dash, P2 dash, P3 dash, P4 dash, P5, P6, P7 dash, and we got already P8 over here, this point. Now just draw light stroke lines. Now I'm satisfied with my arc, then that. This is the hypocycloid curve, the bottom one, and here also same method we have to follow. Any of the point on the curve, make it M. From there, measuring the radius onto the center. From here, you have to draw the point up to this. Here's the point you got. From there you have to draw a line that forms a normal, and straight perpendicular to that becomes your tangent. This is normal for hypocycloid, and this is tangent for hypocycloid. This is hypocycloid, and this is epicycloid. Epicycloid, circle rolling outside the directing surface. This is directing surface, and these two are your generating circles. And this is the tangent for tangent and normal for the hypocycloid, and this is the tangent and normal for the epicycloid. I hope everyone understand by this, and do subscribe the channel for more upcoming videos in drawing using drafter. Thanks for watching.